Hello viewers and my dear students. Welcome to session 1 on the new problem 5 on analysis of beams. Here I will be showing you a demo on overhanging beam with moment using Ansys Mechanical APDL to obtain bending moment and shear force diagrams only. Here I will be concentrating in session 1 and session 2. We will be concentrating on this overhanging beam with moment, and you'll be concentrating only on getting bending moment and shear force diagrams only. Okay, the problem is this. The problem is this. You see here, this is a beam and it is supported here and it is supported here. And there is a overhang here. Can you see overhang of 1 meter? And you have a load here also, 6 kilonewtons. And there is a 6 kilonewton here also. And there is a moment also, anti-clockwise moment, 12 kilonewton meter. This anti-clockwise moment also is there. This is the problem. For this problem, an overhanging beam subjected to loads as shown, determine the following, assuming beam has a rectangular cross section. Any cross section, it can be 0.2 into 0.3, taking E to be 210 GPa, Poisson's ratio 0.27, and you have to determine reaction at the supports here. What are the reactions of the supports? Bending moment and shear force diagram using theoretical methods, and use Ansys Mechanical APDL to verify the above answers. These are all the standard questions given in the examinations and all that. Okay, now you see here. Now this is the problem. Let us say this is the problem. This is 12 kilonewton meter, one anti-clockwise moment is there. There is a load here. There is a load here. I call it as A, B, C, D, E. Okay. RA is the reaction at A. RD is the reaction at D. And you have a load say, at overhanging, no? At overhang of 1 meter. At E, you have a load of 6 kilonewton. At C, you have a that is a load of 6 kilonewtons. And there is a anti-clockwise moment of 12 kilonewton meter. Okay. Now to find reactions, what you do is RA plus RD. Okay. RA plus RD is equal to 6 plus 6. That is downward forces are 6 and 6. 12 kilonewtons or 12,000 newtons. Then you take moments about A or E, whatever is convenient to you. Let us say I'll take moments about A. Then I have told you all anti-clockwise moments I'll take positive, clockwise moment I'll take negative. Okay, in that way, taking moments about A, 6, this is 6 into 7, no? This is clockwise moment. That's why you take negative. Minus 6 into 7 plus this is anti-clockwise. Okay, RD into 6. Then again, this is minus 6 into 4. That is clockwise moment. Minus 6 into 4 plus this is anti-clockwise moment. You please understand this is anti-clockwise moment. That is why I have taken plus 12. Okay, plus 12 equal to 0. And if you substitute 6 RD is equal to 54 kilonewtons, or RD is equal to 9 kilonewtons you get, or 9,000 newtons you get. In that way, once you get RD is equal to 9,000 newtons, RA plus RD is 12,000 newtons, RA will be equal to 3,000 newtons or 3 kilonewtons. In that way, you are finding the reaction at the supports. Okay, next you see here, we will do the shear force diagram calculations. Same thing you see, this RA we have just now calculated 3 kilonewtons, RD 9 kilonewtons and all that. Same 6 kilonewton load here, 12 kilonewton meter moment here or couple here. Okay, this is the shear force diagram calculations. Shear force between D and D. D and D, I have told you downward is negative. Okay, upward force is positive. Shear force between D and D, if you take any section plate, to the right of it, it is 6 kilonewton downwards. That is why it is 6 kilonewton or 6,000 newtons downwards. That is negative. Okay, 6 kilonewton. Shear force between C and D you take. C and D here, to the right of it, what all the forces you have, you see. Downward you take it negative, upward you take it positive. Shear force between C and D, minus 6, RD you have calculated already, plus 9. 3 kilonewtons you get. Did you follow? That is, shear force between C and D is minus 6 plus 9, 3 kilonewtons. Shear force between B and C also, B and C, it is minus 6 plus 9 minus 6. That is minus 12 plus 9, that is minus 3 kilonewtons. Again, shear force between A and B also, it is same as this, minus 6 plus 9 minus 6. For shear force diagram calculations and all that, this moment will not come into picture. In that way, minus 3 kilonewtons only you get. Now you see here, you draw the shear force diagram. Okay, between E and D, it is minus 6 kilonewtons. minus 6 kilonewtons or minus 6,000 newtons. Okay, this is downward negative. Between C and D, okay, it is 3 kilonewtons or 3000 newtons. This is 3000 newtons you do, C and D. Okay, and between C and B and B and A also, C and B and B and A, it is minus 3 kilonewtons only or minus 3000 newtons. It is this way. That means this is minus 3000 newtons, this is plus 3000 newtons, and only between E and A you have shear force minus 6000 newtons. This is the shear force diagram. What you have to do, and you have to show at least in this way in the exam. Clearly show the calculations and write the shear force diagram using pencil and scale in that way. Make it as neat as possible. At least this finish you give. And whatever we have got now, it has to be verified using Ansys later on. Now shear force diagram is over. Then bending moment will go. Bending moment, same thing you draw. Okay. See here 3 kilonewtons, 9 kilonewtons and all that. This is 12 kilonewton meter, 6 kilonewtons is okay. Bending moment at E, that is 0. Naturally, at the support it is 0. Okay, that is at the end. Bending moment is force into distance. No, at E it is 0. Bending moment at D, you see. At D, it is clockwise moment. That's why you take negative 6 into 1. That is 6 kilonewton meter. Okay, 6 kilonewton meter or 6000 newton meter. That is minus, okay, minus 6 kilonewton meter. That is why if you see here D, I have taken minus 6 kilonewton meter correctly, minus 6000 newton meter. Okay. Then if you want bending moment at C is minus 6 into 3, minus 6 into 3, then 9, this is RD is 9 kilonewton, no? 9 into 2, 6 into 3, minus 6 into 3, plus 9 into 2. This 9 into 2 plus, because it is anti-clockwise moment. This is clockwise moment. Minus 6 into 3 plus 9 into 2, that is equal to 0 only. That is, bending moment at C is 0. Okay, that means you have it on the line only 0. Okay. Then bending moment at B you first find out first without the moment. Bending moment at B is minus 6 into 5 plus 9 into 4 minus 6 into 2, that is minus 6 kilonewton meter or minus 6000 newton meter. Bending moment at B is minus 6000 newton meter or minus 6 kilonewton meter. Correct? No? I am telling you again. Minus 6 into 5. This is anti-clockwise. Minus 6 into 5 plus this is anti-clockwise. This is anti-clockwise. This is clockwise. Minus 6 into 5. That's what I given. Plus 9 into 4. Again, this is clockwise. Minus 6 into 2. Minus 6 kilonewton meter or minus 6000 newton meter. That is bending a moment at B. Okay. Bending moment at B considering the moment also. Bending moment at B considering moment also. See here. Bending moment at B due to couple. That is moment at B is already you have minus 6 plus 12. This is anti-clockwise moment. No. That is why you take 12. Minus 6 plus 12. 6 kilonewton meter or 6000 newton meter. That is here minus 6 kilonewton meter. Here this point is without the moment or without the couple. But this point is with the couple. 6 kilonewton meter. This is the thing you got. Okay. This is what? Bending moment at B with the couple. Due to couple at B is 6 kilonewton. And bending moment at A is 0. In that way, this is the bending moment diagram. What you have to write in the exam. And this has to be verified using Ansys. Okay. I think this is pretty clear. And what I have given here is this is 6 kilonewton meter, 6000 newton meter, 6000, the same thing. Bending moment diagram should be in the same way you should get in the exam also. Okay. Now we'll verify this Ansys also. Okay. Now as you see in the Ansys, we'll see here first as usual I have already done file, change job name I have done. Okay, first change job name I have already entered Gurdat overhanging beam. Yes, you do, say okay. Okay, once you do this Gurdat overhanging beam, that will be there. The same file, change title also you do, beam analysis with overhang and moment, beam analysis, beam with overhang and moment. That's also you do. This also beam analysis, beam with overhang and moment. This also you get. These things you already got. Okay, this is the thing. Even if you don't do also, nothing will happen. But if you do that, you are creating a new log file. That is important. I told you the log file importance and all that. This can be copied and pasted and you can analyze it very fast. That I have already told you. Keep trying on this. This is another method. What I'm showing you is graphic user interface. For this, whatever I'm doing now, that is enough. But this method also for the interview purposes and all that, this is very important. Log file operation or macro operations, how you operate macro and all that, they'll ask you. Okay, this I have shown you in the previous sessions and all that. I can show you here also. Whatever is that, you just copy and paste and you get the same answers. You can change the load, you can change the boundary conditions, everything you can change. Okay, anyway, this you are done up till here. Now we'll start with the problem. Preferences, structural. Okay, this is how you start. Now you see in the exam, you don't have to worry about the log file operation and all that. But that is for your understanding purposes. You should know the method 2 also. Okay, that method also you should know. But from here actually you do in the exam. Okay, file that is first clear on the, that is create a new job name and give the title and you start here. Preferences, structural. Okay. Okay, preprocessor, element type, add, edit, delete. You click on add. Take beam 188 only. Okay, beam 188 only, because for all beam problems, you take beam 188 only, which asks for the section. Whatever may be the section you can do. Whatever may be the complexity in the section, we'll do that later on. The complex sections also we'll do. Now it's all very simple section, rectangular section, 0.2 into 0.3. Okay, this is that. Okay, you do this. Then real constant it does not ask. We'll do in the material properties. In the material properties, material models, structural, linear, elastic, isotropic. Here 210 E9 you put and 0.27 is the Poisson's ratio, 2.1 E11 or 0.27 Poisson's ratio. This is the Young's modulus. It is in Newton per meter square. 210 into 10 to the power of 9, that is gigapascal, Newton per meter square. Compulsorily you should have everything in newtons, everything in meters only here afterwards. Okay, that means automatically you should do the modeling in meters only. Okay, then you just say okay, material, exit you do. Okay, then sections you go, beam go, beam you click on beam, click on common sections. You see here, if you click on common sections, B is 0.2 they are given, like any other problem, 0.3. You see here, whatever may be the problem, whatever is the section they get, you just add it here. B is 0.2 here, in another 0.5, 0.75, 0.5, 0.75, in that way you do. See the cross section and put it here. 0.2 and 0.3 is the cross section here, B 0.2, H 0.3. In that way you just say okay. Okay, in that way you just say okay. Then once you do this beam section and all that, okay, then you go for modeling. Modeling, create key points in active coordinate system you have to do. Okay, see here, when you do an active coordinate system, you have to have the modeling of the entire thing. These things you see here, this key, as you know, this is the model to be created. Key point 1 is 0, 0, 0. Key point 2 is 2, 0, 0. Key point 3 is 4, 0, 0. Key point 4 is 6, 0, 0. Key point 5 is 7, 0, 0. In that way, you have to create the key points and all that. Okay. Okay, key points. In that way, once you have created the key points and all that, we'll do. This is, now now we have come to the end of session 1 on overhanging beam with moment. We'll continue this problem in session 2. Okay, please watch my next session, session 2, to complete it. Thank you very much, friends. Thank you for watching. Thank you.